Now problem set 2.6 solution to 2.88. What we have been doing in problem set 2.6 so far. We are considering the turning effect of a force about a given point, that is moment of a force, which is nothing but the product of the force and the perpendicular distance from the point about which it will produce a turning effect. And using that, we have been solving numerical problems so far. So here in the given numerical problem, find the magnitude of the pull P exerted on a nail C. And this C is a nail. It is fixed to this platform. It is fixed to this platform like this. If a horizontal force of 178 Newton is applied to the handle, in the diagram it is given 180, so let me change it here to as 180 Newton is applied to the handle of the raking bar as shown. Now very simple. Look at this portion is a raking bar. Look at this one. This is the handle where you are applying a horizontal force of 180 Newton. This is the raking bar. Right. The raking bar is holding the nail C at this point. And when you apply a horizontal force here, 180 Newton like this point, let me call this point as B. So the raking bar will be rotating, will be turning about the point B. The point B will be the fulcrum. So due to this 180 Newton, the raking bar, this raking bar ABC, which is turning about the point B. So this 180 Newton force has a perpendicular distance 300 millimeter. So this 180 into this perpendicular distance will have a turning effect about the point B in the clockwise direction. So when the raking bar turns about the point B due to the turning effect of this force, which is equal to 180 Newton times this, the nail will be pulled up. So now look at ABC is the raking bar. 180 Newton is applied to the handle at A here. B is the fulcrum about which the raking bar turns due to moment of this force 180 Newton. So 180 Newton into this perpendicular distance is a clockwise moment. Now look, now is interesting. Now, when this part of the raking bar is pulling it up, an equal and opposite force, that is the pulling force, I have shown it this way. It is given this angle is as 20 degree. Now, if you split this pulling force P to a horizontal and vertical component, this will be your P times sine 20. I have not drawn another diagram for you, and this will be your P times cos of 20 degree, P cos 20. And we are considering the moment, so instead of considering the moment of the pulling force P about B, I can consider separately the moment of its two components, that is the moment of P sine 20 about point P and the moment of P cos 20 about point P. Now P sine 20, which is the component of P to this side, will pass through the point B. So P sine 20 does not have a perpendicular distance from the point B. So P sine 20 will not produce a turning effect about point B. Whereas P cos 20, P times cos 20, which is acting from this point to this side, is at a perpendicular distance 40 mm. So P cos 20 will provide an anti-clockwise movement about the point P, and that will be P cos 20 times 40 mm. So I have not rewritten. So P cos 20 and P sin 20, the two rectangular components of P at the nail C. P sin 20 doesn't have a perpendicular distance from point B, so it does not produce a turning effect about point B. So we neglect that. But P cos 20 has a perpendicular distance 40 mm from point B. Therefore, the anticlockwise movement of P cos 20 about point B is P cos 20 times 40. And this is anticlockwise, and the first one was clockwise. And so on the point of equilibrium, therefore, both are equal. So P cos 20 times 40 is 180 times 300.8. So P comes out to be 180 into 300.8 over 40 times cos 20. If you put it in a scientific calculator, comes out to be 1440.471 Newton. So this is the pull applied to the nail, right? So you might be considering why the P is to this side. Look, there must be an action-reaction force. Whatever action force we are providing to this side, the same reaction force is to this side. So I have taken P to this side. So very simple. I have not redone the diagram for you. Let me explain once again. 180 times this perpendicular distance is a clockwise movement about point B, means it will try to rotate. The raking bar will try to turn like this about point B. Due to that, this nail will be pulled up. But at here, if you take this as the direction of the pulling force, one component is P sin 20, this will be P cos 20, because this angle is given as 20. P sin 20 passes through the point B, so it does not have a turning effect. P cos 20 has a perpendicular distance 40 mm, so has a turning effect about point B. So both are equal and opposite, so that gives us P as equal to 14,1440.471 Newton.